Welcome back to Josh Does Math. In this video, we're going to be finding the equation of the normal line to this big equation that's given right here. So we have some complicated curve. I have no idea what it looks like, so we'll say it just looks something like this. And I'm looking for the equation of the normal line to the curve at a certain point. So let's say that this is the point I'm looking at. We know that the tangent at this point is going to be the point that touches the curve once. What's the normal at this point? Well, the normal is perpendicular to the tangent, so we'll say that this is the normal right here. And there's our right angle. So first of all, maybe before we find the equation of the normal, it would be easier to start working with the tangent that we know how to work with. We know that the tangent has the same slope as the curve at that point. So a good first step here is to find the slope, you can say, of the curve at that point. And to do that, I'm going to take the derivative of the curve. dy dx is equal to d, this big monstrosity of an equation right here, 1 minus 2x plus 3x squared over 1 plus x squared. So you can tell I'm going to be using the quotient rule right here since I have a quotient. So that's what I'm going to do in this next step. Derivative at the top, that's going to be negative 2 plus, I'm using the power rule right now, 6x times bottom, 1 plus x squared, minus derivative of the bottom, that's going to be 2x, times top. And here we go, 1 minus 2x plus 3x squared, all over bottom squared, 1 plus x squared, all that is squared. So now what do we do? Well, simplify this down a little bit. So I'll do FOIL in the numerator here and distribute this 2x here. So I'll get negative 2 minus 2x squared plus 6x plus 6x to the third minus 2x plus 4x squared minus 6x to the third. And this is still all over our big denominator here. And there's still a little bit more work to be done. In the numerator here, we can do some combining of terms. So we're still stuck with that negative 2 in front. Our linear terms, we have a 6x and a negative 2x. That looks like a 4x. How about our second power terms, negative 2x squared and 4x squared, so that looks like a 2x squared. And our third power terms, we got one right here and one right here. They perfectly cancel, so you have this over 1 plus x squared squared. So that's great. That gives us the rate of change at every single point on the curve. You just plug in your x value. But that doesn't give us the rate of change at the specific x value. So I'm just going to plug in our x value, which is, we're given 0 right here. We're looking at the point 0, 1. So dy dx, evaluated at x equals 0, is going to just be this derivative equation right here, but I'm plugging in 0 for every x. So as you can see, if I plug in 0, that term goes to 0, that term goes to 0, and that term right there goes to 0. So I'm left with negative 2 over 1, which is negative 2. So I know that the instantaneous slope at x equals 0 is negative 2. So that's going to give me the slope of my tangent line. What is the slope of my normal line? Well, I know that the normal line is perpendicular to the tangent line, so they must have negative reciprocal slopes. That's just something that you should know about slopes that are apart by 90 degrees, just like this case up here. So negative reciprocal slopes. So what's the negative reciprocal of negative 2? That's going to be 1/2. So I know that the slope of my line is 1/2. Slope of my normal line. So now, how can I find the actual equation of this normal line? Well, I know a point that it goes through. That's right here, 0, 1. And I know the slope. That's right here. If I know a point on the line and the slope, I can use point slope form to figure out the equation of the line. So I'm going to write y minus 1 is equal to m 1/2 times x minus 0. That's just point slope form. That means y is equal to 1/2 x plus 1. And that's the whole thing. So that's the equation of the normal line. And as you can see, I just took the derivative, and from there, I plugged in a couple of numbers, and that's all there was. And I'm able to find the normal line to this curve. Thanks for watching.